Okay, from the definition of a parabola, one can derive the standard form of the equation of a parabola. And this standard form might be different from what you've seen before. So this is with a vertical axis. It looks like this. 4p, remember p was the distance between the vertex and the focus. So 4 times p times the quantity y minus k equals the quantity x minus h squared. So the form we saw before was y equals a times the quantity x minus h squared plus k. And this has just been rewritten. But in this formula, the a is the same as 1 over 4p. If you look at it carefully, you'll see if you put this 4p on the right side of the equation, it would be 1 over 4p. And that's right where the a is on this form down here. This one. Right, so take the 4p, cross multiply, you end up with 1 over 4p. That's the same thing as a. Then the k has just been moved to the left instead of being on the right here. You just move it to the left. So they just moved k to the left and divided both sides by a, which happens to be 1 over 4p. So you should know these. A is 1 over 4p, and p is 1 over 4a. If p is greater than 0, then the parabola opens up. If p is less than 0, the parabola opens down, the same as a. Of course, if p is positive, then a will be positive, as you can tell from these equations. And if p is negative, a will be negative. So that's why that works. Okay. So p greater than 0, hk, from this formula, h comma k will be the vertex, and x equals h is the axis. Then from the vertex you go up p, and you get the focus. So the focus is going to be h comma k plus p. And then if you go p in the opposite direction, you get the directrix, which is y equals k minus p. The second coordinate here, minus p, because you're p lower. Okay. And this distance here, you go over 2p, in both directions from the focus, and you get, which makes these two little squares, and you get 2 more points on the parabola. So when you're dealing with parabolas in this form, with the p in there, this is how you find 3 points on the parabola. The vertex will be here, halfway between the focus and the directrix, and then you go from the focus, you go over 2p. So over this distance to the left and over to the right to get this. Now if p was negative, this whole thing would be upside down. You'd go down p and down another p, then left and right p. The absolute value of p, actually. So you just flip this whole thing upside down if p is negative. So the graph looks kind of like that. Okay, so for a horizontal axis, so that's a vertical axis, a horizontal directrix, but a vertical axis of symmetry. So for a horizontal axis of symmetry, you just switch what I did here is I just switched the y minus k and the x minus h. I switched where they are. See, so you get the x minus h on the left, not squared, and the y minus k is now squared on the right. So that's the only difference between these two. You switch the x minus k and the y minus k and the x minus h to get this one. And now you have a horizontal axis of symmetry, which means you have a vertical directrix. And now when p is positive, it opens to the right, towards the positive x-axis. And when p is negative, it opens towards the left, towards the negative x-axis. So I think I just wrote down the switch that I made here. So we switch the roles of x and y, which includes the x and y coordinates of the vertex with h and k. So this is just for p greater than 0, just as a demonstration. So you have the vertex hk, which you can read off of the standard form up here. Right, hk. You set this equal to 0 and solve. That gives you h. Set this equal to 0 and solve, and that gives you k. That's the axis of symmetry. It goes through the vertex. It's horizontal. You go over p. And this is with p positive. And the focus will be h plus p comma k. And then you go the opposite direction p, and you get the directrix. So that'll be an equation of a vertical line, which means you need the x equals part. Don't just write h minus p. It's not a number, it's an equation of a line. X equals h minus p. Okay, so that's just the x coordinate minus p on the right side there. Okay, and then to find 2 more points on the parabola, you go over, now you kind of looking at it sideways, you know. You go over 2p and over 2p. So actually it's up 2p and down 2p to form these 2 little squares. And then it goes through the corners of that square. The corners away from the directrix. And you just draw the parabola in.